Hello, everybody. So what we're going to be doing today is we're going to be looking at your practice exam 1. And this may be split over 2 videos. It depends on whether I finish this in time for the office hours that I'm going to be doing in an hour. So let's just get right into it then. So we have the information for the exam right here on the left. Of course, if you're looking at this in a future semester, then this will not be accurate. But yeah, so your real exam will be 10 questions like these questions. And yeah, let's get started. So we will refer to this unit circle a number of times while we do this exam, and I would strongly recommend that you print out a copy of this yourself. Not necessarily this, but from the handouts page where there's a better copy of it. All right, let's get straight into this. We're going to do these in order and see how we go. We're going to need a calculator at various points as well. All right, so number 1. So we've got this triangle here in problem 1. And okay, we have theta. We don't know what angle theta is. So we don't know, is it 30 degrees, 20 degrees, 50 degrees? We have no idea. But what we do know is that these two sides of the triangle are labeled 6 and 2. And in right angle trig, here's what we know. So right angle trig. I said right angle trig, that's not the right word. I want right triangle trig. So here's what we know. We know that in right triangle trigonometry, there's an angle that we label theta. And then the other 3 sides are called the opposite side, the adjacent side, and the hypotenuse. And when we have them labeled this way, we know that sine theta is opposite over hypotenuse. Cosine theta is the adjacent side over the hypotenuse. The tangent of theta is the opposite over adjacent. And then there's 3 more. We've got the secant of theta is an upside down cosine. It's the hypotenuse over the adjacent. The cosecant of theta is an upside down sine. It's the hypotenuse over the opposite side. And then finally, there's a cotangent, which is an upside down tangent. So it's the adjacent side over the opposite. And also in a right triangle, we have the Pythagorean theorem, which I will draw. So right angles there. And the relationship for a right triangle is that a squared plus b squared equals c squared, right? So that's everything you need for a lot of the problems on here. And we will get started. So this first triangle that we have here, we're missing one of the sides, right? We're missing this side, which if I label it with the same labeling as here, we're missing this side A. Okay, so we need to find that before we do the trig functions because we're going to need that side. So we start with the Pythagorean theorem, which says a squared plus b squared equals c squared. We fill in the numbers that we have. We're going to leave a as a because we don't know it. So a squared plus 2 squared is 6 squared. So we have a squared plus 4 is 36. We're going to need to find a, so we should subtract 4 from both sides. So a squared is 32. And then a, we're going to square root here. And so we have the square root of 32, which you can simplify if you want to. You don't really need to. But 32 is 16 times 2. And then the square root of 16 is 4. So I can write that as 4 root 2. Maybe I will, maybe I won't, depending on what we're working on. So we have the side now. So I can come up here and I can just erase this maybe. Well, I'll leave it. And we'll say that this is 4 root 2. Okay, so we've got that side. Now, once we have that side, we should easily be able to find the cotangent, the cosecant, and the cosine, right? So we'll just do these in whatever order. I guess it doesn't really matter. Don't know why I switched colors. So the cotangent of theta is, according to the definition, the adjacent side over the opposite, right? I'm just looking right here. And we know what those sides are because I didn't label them here, but I'm trying to zoom in and it's not working. We didn't label them here, but this is the opposite side. This is the hypotenuse. And then down here is the adjacent. So if we're looking for the adjacent side over the opposite side, the adjacent side is 4 root 2, and the opposite side is 2. And if you want to simplify that, you can, and you would have 2 root 2 as your answer. So that's the first box. Then we got the second box is cosecant theta. So cosecant theta, again, we just look at our formulas, hypotenuse over opposite, hypotenuse over opposite. Reading our triangle, the hypotenuse is 6 and the opposite is 2. So that is 3. So that's what goes in our second box. Third one is cosine. Cosine is adjacent over hypotenuse. So the adjacent side is 4 root 2. And the hypotenuse is 6. And if you want to simplify that, that's 2 root 2 over 3. And there we go. So we're just using these formulas. And anything with the right triangle is probably just going to involve that exact same set of formulas. All right, next question. So number 2. So a plane rises from takeoff, flies at an angle of 10 degrees. I think from the picture it's clear where the plane started. Plane started at A, and now it's at B. 10-degree angle with the horizontal, has gained 500 feet. You can see the 500 feet in the picture. Find the distance to the nearest foot the plane has flown, and that is what's labeled C. So we have to find C in the picture. So our triangle that we've got here, which you don't have to draw it like perfectly matching the picture, just get it close. So this is 10 degrees. We don't know C, and this is 500. Okay, so we're not being asked for like sine theta, cosine theta, anything like that. We're being asked for C. And you can't just use the Pythagorean theorem, because in order to use the Pythagorean theorem, right, like here we could, because we knew 2 sides and we were only missing 1. So we had 2 numbers to fill in and only 1 variable. If you tried to do that with this triangle, we would be stuck because we're actually missing 2 sides, right? Like the A and the C, we were missing both of them. We only know the 500, right? So this right here, if I put in an A, which we don't need, but I'll put in an A, right? Like how are you going to find C and A with the Pythagorean theorem, right? You're going to have 2 variables and you can't solve the equation. So you can't use the Pythagorean theorem. What you can use is trigonometry because they told you the angle. So you write out a trig function that relates the sides. So if the angle's here, then this side is the opposite side, this side is the adjacent side, and this is the hypotenuse, right? So the thing that we know, the side that we know is this one. And the side that we want is this one. So we've got hypotenuse and opposite. Those are the ones we want to deal with. The one that we know and the one that we want. So we look for a trig function involving the opposite side and the hypotenuse. You look at your list and you'll realize that the one that you want is this one, sine. sine theta is opposite over hypotenuse. There's another one over here, cosecant, that also involves the hypotenuse and the opposite, but you don't want to use it. And the reason you don't want to use this one is because if you're using a scientific calculator, you do not have a button for any of these three on your calculator, but you do have a button for these three, sine, cosine, and tangent. So we stick to those just to make it easier. If you use a computer, well, it doesn't really matter. So the sine of theta in general is the opposite over the hypotenuse, right? So what you do is you fill in what you know. And what we know is that the angle is 10 degrees, and we know the opposite side is 500 degrees, and the hypotenuse we don't know, but it's called c. And then what you would need to do is solve this for c. So you can punch sine 10 degrees in a calculator if you want to, or you can wait until the end. I'm going to wait till the end and then punch it in. But so what I would do is I need to solve this for c. So I'll multiply by c on the left and over here. That makes it, cancel. So I get 500 equals c times sine of 10 degrees, which I don't know yet. Then if I'm trying to find c, I should divide both sides by 10 degrees. So c is 500 over the sine of 10 degrees. Okay, and then this I just need to put into a calculator and to calculate. Now be careful. I'm going to go to Wolfram Alpha to do this. So this is the site that I like to use for calculations. Be careful. If I do 500 over sine 10. Now, it's probably going to interpret that 10 as 10 degrees. But you have to be careful, because if I do sine 10 degrees, I'm going to write that, just write 10 degrees there, then I get a number, 2879, okay? If I write 10 radians, then I'm going to get a different number. Where's the number? Well, it did the wrong thing. But the point is if you do have radians there, instead of degrees, you will get the wrong answer. And if you use a scientific calculator, you need to make sure that you're in degree mode. There's a degree mode and a radian mode. So just be careful. So this one here, I've got the answer, 2879. That's going to be in feet. Then it says find the distance in the nearest foot. So we need to round it. Yeah, that is rounded to the nearest foot. Oops. What am I doing? Right. Okay. So there we go. So be careful. That's all I have to say. Degree mode versus radian mode. Know the difference. All right. So that's number 2. So on to number 3. Guess I was writing the numbers in blue for some reason, so I'll switch back. Blue. Convert the following angles in radians. So this is a typo. They are in degrees, right? You see the degree symbol. So we need to go degrees to radians here. So sorry about that typo. So let's do it. Easy peasy. So 135 degrees, you multiply by a conversion factor, 180 degrees, which you put on the bottom, is equal to pi radians, which is what you put on the top. You know that that's the correct way around because you want the degrees on top to cancel with the degrees on the bottom. So we've got 135 pi over 180, right? I'm also going to do the other one while I'm at it, and then I can just go to the calculator one time. So negative 40 degrees times pi radians over 180 degrees, and I'm going to get negative 40 times pi over 180, and this will be in radians, and let's go to a calculator, see what we get. 135 pi over 180, and there we go, 2.3. So I don't know what I'm supposed to round it to, so I'm just going to write 2.36. Radians, that's as a decimal. Or you can just leave it as a fraction, which I'll type it in here and you'll see 3 pi over 4. So I could just leave it that way, 3 pi over 4. That's a better answer. Okay, but it's about 2.36. For the other one, we just need to change that 135 to a negative 40 pi, and that is negative 2 pi over 9, or if you want a decimal, negative 0.698, but that would round up, so 0.70. Okay, you can also feel free to reduce this by hand, right? 40 over 180, if you reduce that by hand, 40 over 180, you can cancel a 10 and get 4 over 18, and then you can cancel 2 goes into 4 2 times, 2 goes into 18 9 times, and you can get the 2/9 yourself. So you don't have to use a calculator there, but I am. Next question. We are down at number 4. So number 4 is going the other direction. So convert radians to degrees. Let's go. So the first one is 7 pi over 6. So 7 pi over 6. We have basically the same idea as last time, but this is in radians. So when we convert it to degrees, you use the same conversion factor, but this time you put the pi radians on the bottom and you put the 180 degrees on the top. So it's the same conversion factor, right? It's just upside down. And we do it this way for the same reason. This time we want radians to cancel, which they will. Also, generally speaking, you're going to have like a pi on top and bottom that also cancels. So what you end up with here is on top just the 7 and the 180 degrees. 7, 180 degrees, and then on bottom it looks like all I've got is a 6. So 7 times 180 over 6. So again, that's just a punch it into the calculator kind of a thing. 7 times 180 over 6, 210. 210 degrees. Okay. The other one is going to be very similar. So 9 pi over 2, that is in radians, multiplied by our conversion factor, which is pi radians and 180 degrees. The pi will cancel, the radians will cancel. You're going to have 9 times 180 degrees, and it looks like a 2 on the bottom. So 9 times 180 over 2, it was what, 810 degrees. All right, so that's all there is to that. Next question. Okay, unit circle trig. So the topic's kind of skip around a little bit on the exam. They're not completely in order, like order that they are in the textbook. Here we go. So notice that this point here is specifically labeled as being on the unit circle. That's important. Very important, because if you have a point on the unit circle, then what you're going to be able to do is use these unit circle formulas for the angle. So let me just draw a little picture here just to make sure we understand. So we've got the unit circle and you've got this angle, or there's an angle somewhere. Since the x and the y are negative, I know it's going to be like down here somewhere. That's my theta. They didn't tell you theta though, right? They didn't tell you theta, so I don't know exactly what it is. But what I do know is that right here, this point is negative 2/3, negative root 5 over 3. So that's the picture for this. And then to actually do these calculations, we have sine, cosine, tangent, secant, cosecant. I skipped cotangent, it looks like. That's to have 5 things instead of 6. Just makes it easier to grade. So let's go ahead and do this problem. We've got sine theta. Sine theta is just going to be the y value. So you read that. Well, you just write it. There it is. Cosine theta is the x value. So it's negative 2 over 3. What's next? Tangent. Tangent theta. Tangent theta is y over x. So that's negative root 5 over 3 over negative 2 over 3. The negatives cancel, the 3's cancel, and I'm going to get root 5 over 2. Feel free to put that into a calculator if you are confused. Next one, secant. Secant theta is 1 over x. So it's 1 over negative 2/3, which is negative 3 over 2. We have the cosecant of theta, which is 1 over y. So it's 1 over negative root 5 over 3, which is going to be negative 3 over root 5. And that can be rationalized. Like, this is technically the correct answer, but we don't like having the square roots on the bottom. So to fix that, you can multiply it by root 5 over root 5. And you'll end up with, on top, negative 3 root 5, and at the bottom, just 5. If you just wrote this, you're still correct, but you haven't written it in the most simplified form, which is the one on the right. This problem does not ask for cotangent, but if it did, cotangent is x over y, which would be negative 2/3 over negative 5 over 3, negative root 5 over 3, which is 2 over root 5, or using the same process as the problem above, 2 root 5 over 5. So remember, this one was not asked for, but the other 5 were. So those formulas are what you use for unit circle trigonometry. So we did it. So what's next? Number 6. Okay. Now this time, number 6, we're given a point. So the point negative 4, 3 is not on the unit circle. Okay, so in that case, there's an extra step compared to the previous problem that we did. And I have a specific way that I like to do this, but you'll find other ways like in the book. So, it is what it is. I'm just going to show you the way that I do this. So the way that I do this, this line's crooked, let me fix it. So the way I do that is this. So we've got a circle. This is not the unit circle. not the unit circle because I'm going to put the point that we have, which is -4, 3, like somewhere like here on the unit circle. Sorry, not on the unit circle. And it's not the unit circle because the radius is not r, or is not 1. So this is the picture that we have. We still have the same thing going on as the previous problem where this is your theta. And here's the thing that you have to do. So since this is not the unit circle, this length right here from here to here is not 1. It's supposed to be 1. If I label it as r instead, then what we have is this. So there's a Pythagorean theorem on this where the x squared plus the y squared would be the r squared, where r is what I just drew. And then after you use this to find r with that formula, or this one, you could also use, if you just square root both sides, you could just say r equals square root x squared plus y squared. Once you use that formula to find r, then the formulas you can use are as follows. You could use that the sine of theta is not going to be y. It's going to be y over r. You have to divide by r because, again, this is supposed to be 1 on the unit circle, but it's not here, it's r. And so this fixes the formula to work when the point is not on the unit circle. So the cosine is x over r. The tangent is y over x. The secant is r over x. The cosecant is r over y. And the cotangent is x over y. So the top 4 formulas here, right, these two and these two have r's in them. And that's different than above. And that's all because the point is not on the unit circle. So for this problem here, what we've got is just step 1 is, find r. We know that r is going to be the square root of x squared plus y squared. So it's going to be the square root of, what are our numbers? -4 and 3. -4 squared and 3 squared, which is square root 16 plus 9, right? Which is square root 25, which is 5. So r is 5, right? R is 5. So once you have r is 5, then we should be able to fill out all of these trig functions here. So like sine theta is y over r, the y is 3, and the r is 5. Right? Cosine theta, x over r, the x is -4, and the r is 5. Tangent theta, the y is 3, the x is -4. Secant theta, the r is 5, the x is -4. Cosecant, the r is 5, the y is 3. And cotangent, the x is -4, and the y is 3. So again, there's 6 of them there. I only asked for 5 of them in the problem, but I just wanted to make sure you had all of the formulas. And so that's how you do it. Okay. Oops. Next question. Number 7. All right. Angle between 0 and 360 that is coterminal with 17 pi over 3. I should fix this. So instead of 0 and 360, I should say 0 and 2 pi, right? If we're working in radians. On problem 8, we're doing degrees. Problem 7, we're doing radians. So I should label these correctly, 0 and 2 pi in radians. If you did it in degrees, I would give it credit, but this is what we're doing. So what's the point of this? So the point is that if you take so this is kind of an explanation, not for this problem, but if you take an angle, right? Like let's say, I'm just going to make one up. So like, let's say you have an angle here, like, and this is, let's say it's 20 degrees, right? So that's 20 degrees right there, but you can get to the exact same place if you go all the way around a full revolution and then go 20 degrees, which would be 380 degrees, right? Because that's 20 plus 360. But you could also go around twice. You can go once, twice, and then go there. That would be 20 plus 360 plus 360. So 720 plus 20, which would be 740 degrees, right? And the point is that you can always do plus 360 and end up in the exact same place. Or in terms of radians, that would be 2 pi, right? So, you know, similarly, everything looks more complicated in radians, but like if I had an angle, like let's say that was like, let's say pi over 7, just made up example here. That's pi over 7, but that's the exact same thing as pi over 7 plus 2 pi, which is a full revolution. And if you actually work out what that is, pi over 7 plus 2 pi, right, you'd have to get a common denominator, and it would end up 15 pi over 7. You could add another 2 pi, which I'm not going to show you, but that would be like 29 pi over 7, etc. And all of this is a very long-winded way of saying that you can add or subtract one full revolution and end up where you start. So I know we were looking at problem 7. I'm going to do 8 and then come back to it, okay? Do these out of order for a good reason, I think. So on problem 8, because 8 is in degrees. So same thing, right? Angle in 0 to 360 degrees, coterminal with 800, right? So obviously 800 is not in 300, is not between 0 and 360. So all you do is you just go, okay, since it's not in 360, 0 to 360, just subtract 360, right? Because it's too big. 800 is too big. So subtract 360. What do you get? You get 440. Well, guess what? 440 is still not in between 0 and 360. So do it again. 440 minus 360. 80. So that's the answer to 8. Okay. Which makes sense, right? 80 plus 720, which is 2 full revolutions, gives you 800. So that's the answer to number 8 there. For number 7, same deal, but we had 17 pi over 3. You have to play the same game where 17 pi over 3 is too big, right? Because 17 over 3 is like 6. So that's bigger than 2 pi. So you need to subtract 2 pi. Not 2 pi over anything, just 2 pi. So we 17 pi over 3 minus 2 pi. I want it as an exact answer, so I have to hit enter. What? I'm not asking, I just want you to subtract, man. So you get 11 pi over 3. That's still bigger than 2 pi, so I have to do it again. (11 pi over 3 minus 2 pi). Enter. I get 5 pi over 3. So 5 pi over 3 is less than 2 pi. Like, remember that pi is about 3.14, right? So like 2 pi is around like 6.28. So when we get an answer that's like 5.23, right, you see in the decimal approximation, you know you're between 0 and 2 pi, because 5.2 is smaller than 2 pi. So this is my answer. So one full revolution is 360 degrees or 2 pi. And when you get a number that's too big or too small, you just take that number and add or subtract 2 pi or 360 repeatedly until you get a number that is in the range you want. So we want between 0 and pi, or 0 and 2 pi, or 0 and 360. Obviously, it's easier to do in degrees, but same idea. All right, so that was 7 and 8. 9. So number 9, we've got sine 7 pi over 6, cotangent 7 pi over 6, and secant 7 pi over 6. And you use the unit circle. Okay, so you use the unit circle with what you know about the formulas. So like, remember that on the unit circle, the sine is the y value. And on the unit circle, the cotangent is x over y. And on the unit circle, the secant is 1 over x. Now, those aren't the answers, those are the formulas. So then we go to our unit circle, which I printed one on here to help you out. So all the way at the top, we'll look at our unit circle, and we find 7 pi over 6. So you find 7 pi over 6, right? There it is. And we can read off the x and the y values, right? Negative root 3 over 2, negative 1/2, and we just write them down. So the y value here is negative 1/2. So that's the sine. The cotangent is x over y, so that's negative root 3 over 2 over negative 1/2. You work that out. The 2's cancel, the negatives cancel, you get square root 3. And then what do we got? Secant. The secant is 1 over x, so that's 1 over negative root 3 over 2, which is negative 2 over root 3. And if you rationalize the denominator, as we've talked about, root 3 over root 3, then you get negative 2 root 3 over 3. Say 3 there as your answer. Now, that's how you're supposed to do them. If you have a calculator that can do symbolic calculations, or if you have a, why can't I get a new page? Okay, there we go. Calculators can do these problems. So like if I ask for the secant of 7 pi over 6, I'm just going to get the correct answer. So they wrote it negative 2 over root 3. But, calculators can do these problems as well without the unit circle, but, we're supposed to be using the unit circle. So I did. All right. Problem 10 is probably the same deal, just different things. So the secant of pi over 4 is, well, we'll look in a minute, negative pi over 2. Maybe I'll leave a little bit of space there. Oh, and secant is 0. All right. So one thing I want to do just before we go look at our unit circle is on the unit circle, pi over 4 is going to be easy to find. 0 is easy to find. Negative pi over 2, you might want to, or you might have to think about a little bit, right? So you have to think about the negative direction and the positive direction, right? Like on the unit circle here, this is 0, pi over 2, pi, 3 pi over 2, and if you keep going, back to 2 pi, right? We know that that's how the unit circle works. However, let me get a thinner pencil here. However, if you go the opposite direction, we could go this way. So that would be 0, and this is the minus direction. So negative pi over 2 would be here. Negative pi would be here. Negative 3 pi over 2 would be there, and then this would be negative 2 pi, right? So you always can go in the negative direction. It just won't be printed on your unit circle for you. So when you have negative pi over 2, you have to know that that's right here. Otherwise, you won't be able to do that problem. Okay, find the unit circle. Here it is. All right, so secant pi over 4, we know will be, it's a secant. So secant is 1 over x. And 1 over x will be, well, let's find pi over 4. It's right here. So it will be 1 over root 2 over 2, which if you simplify it, simplifies into root 2. You can punch that into a calculator. Next one is tangent. We know that tangent is y over x. So we need to find the angle, negative pi over 2. We talked about where it is. It's down here, where 3 pi over 2 is. So the y value is negative 1, and the x value is 0. So we have a divide by 0, and that's a problem. So when that happens, we just cross that out and say that the value does not exist, okay? D and E does not exist. So we have to answer that way. No divide, you're not allowed to divide by 0. Another secant? Hold on. What problem are we doing? Oh, secant, tangent, secant. Okay, that's fine. So we've got secant 0. Secant, just like before, is going to be 1 over x. So 0 is right there. And, the x value is going to be 1. So 1 over 1, which is 1. Of course, again, you can type these into a calculator and get answers other ways. So like if I do secant 0, of course, it's just going to tell me 1. If I do tangent negative pi over 2, it says this. Does not give an answer. So, you can't really rely on it. If I type it into like a scientific calculator, generally I'm going to get an error. But we know that it does not exist because of that divide by 0. All right, next question. How are we doing for time? Got like 10 minutes. How many questions? Oh, not that many. Don't think we can finish, but maybe we can. We'll find out. 11. All right. So 11 is just like that second problem that we did, actually. So my advice for problem 11 is don't let the fact that I gave you 2 angles confuse you. Okay? Just pick one of them and ignore the other one. So like, I'll write 30 there. The other one's 60. I don't even care. Okay? So there's my triangle. And this is just like that airplane problem. in terms of that angle, in terms of this angle, this is the opposite side, this is the adjacent side, and this is the hypotenuse, okay? Based on the angle that I used. I could have used the 60. If I use the 60 for my angle here, then my labels are wrong. If I use the 60, then this is the opposite side, and this is the adjacent side. So it's very important that you just pick one angle and interpret everything that way, okay? I guess I'll use the 60 now just because that's what I've got written. So then what you do is, as before, we've got this, we know the opposite side, we're trying to find the adjacent side. So you look for a trig function that involves opposite and adjacent. And so the trig function that involves opposite and adjacent is tangent. Specifically, the tangent of theta is the opposite over the adjacent. So then you fill in your numbers. So tangent 60 is opposite, which is 5, adjacent, which is a, we don't know it. Little bit of rearranging here, just like the airplane problem, and we could have a tan 60 equals 5, or a equals 5 over tan 60 degrees. So this is what I've got, and I just go to a calculator. So 5 over tan 60. And again, be careful that you are in degrees, right? I can see the degree symbol here, so I know that this calculator did the right thing. And so this is 5 over square root 3, or a decimal 2.89, roughly. Okay, so that's it. Next one. Another triangle. Same exact process. 8, that's the right angle, believe me. It might not look like it. 45 degrees there. And again, I only need to pay attention to one angle. So my sides are, this is the opposite, this is the adjacent, this is the hypotenuse. So I know the adjacent and the hypotenuse, so I'm looking for a trig function involving hypotenuse and adjacent. And the trig function I know is the cosine. So the cosine of 45 degrees, or let me write just in general, cosine theta is adjacent over hypotenuse. And then I fill in what I know. So the cosine of 45 degrees is adjacent, which is 8, hypotenuse, which we don't know, but it's called h. Again, rearrange this. So move the, the h up. H cosine 45 is 8. Divide both sides by cosine 45, and h is 8 over cosine 45 degrees. So h is 8 over cosine 45. Eight root 2, which is approximately 11.3. So generally you would want to answer this way, not with the decimals. Okay, so those are correct. We are on 12. 12. Guess what? It's going to be very similar. So we've got a triangle in my picture. This is 35. This is 40 degrees. This is h. And h is the height of the tree. That's what we're trying to find. So exactly the same as the previous problems. So in terms of that angle, we know that this is the opposite side, this is the adjacent side, and this is the hypotenuse. So we know the adjacent and we're looking for the opposite. So opposite and adjacent tells us we should be using a tangent because tangent involves opposite and adjacent. Tangent theta, opposite over adjacent. So tan 40 this time is opposite, which is h, over adjacent, which is 35. So for the first time, the thing we're looking for is actually up here instead of previously it was in the denominator, right? So the algebra here is a little bit trickier than this one. Here we just move the 35 up. So you just multiply both sides by 35, 35. And what we get is that h is 35 times the tangent of 40, which you just come here and say 35 times the tangent of 40, which this is not going to have a pretty answer, only the decimal, so 29.37. And that's going to be in whatever the units are, so it looks like we are in feet. Feet. So 29 feet tall that tree is. Okay. So, oh, this is going to be annoying because the last problem's slightly longer and we're almost out of time. Okay, so here there's no issues here. I mean, there's nothing to it. It's just what quadrant we're in. 1, 2, 3, 4. Okay, so on problem A, they say that the cosine of theta is less than 0. And they say that the tangent of theta is also less than 0. And you need to interpret this. So if the tangent of theta, or sorry, if cosine theta is less than 0, remember that the cosine is the x value. So x is less than 0. That means you're here, right? X less than 0 is the left side of the graph. Now, tangent less than 0 means that y divided by x, right, because that's tangent, is also less than 0. So if we know from here that the x is negative, then here we know that the x is negative. But if overall y divided by x is negative, then the top must be positive, right? Why? Because think about it. If the bottom's negative, which we already know, a negative over a negative would be positive. But they tell us it's less than 0. So in order to be less than 0, one's got to be plus, one's got to be minus. So if the x is minus, then the y is plus, which means the y value is positive. So if the y value is positive, you're up here. So combine that information that you're on the left half and on the top half, and you've got to be in quadrant 2. So that's A, quadrant 2. Now for B, they say sine theta greater than 0. What's that mean? Well, remember sine is the y, so y has to be greater than 0. So that means you are up here. And then the other piece of information is that cosine theta is greater than 0, which means the x values are positive. So that means you're over here. Oops, that's not what I want. That means you're over here. So where do they overlap? Where are both of those things true? Quadrant, not 2, quadrant 1, right? Upper right. Why can't I write? So A is quadrant 2 and B is quadrant 1. Okay, last problem, which we'll have to do quickly because I've got 5 minutes. So sorry about that. All right. So what's going on here? So we've got a unit circle. And we're in quadrant 4, which is down here. And the sign is -5/6. So that's the y value. So like down here, -5/6. There we are. So there's an x value we don't know, and the y value is -5/6. Okay, that's what we know. Now what we want is the secant and the cotangent, which in order to find those, we need to know the x value. So your step 1 here is going to be find x value with the equation of the unit circle. Remember this, x squared plus y squared equals 1. So you plug in what you know, which is that y is -5/6, and find x. So x squared plus 25/36 is 1. Move this over. X squared is 1 minus 25/36. Punch that into a calculator. You're going to get 36 minus 25 is 11. 11/36. And then x is going to be plus or minus square root 11/36. Yeah. So that is, by the way, plus or minus root 11/6. Okay, so yeah, so that's what you get. Now, it's not both the plus and the minus. That's where you have to remember your picture. We are down here in quadrant 4, which means the x value should be positive. So the x value here is going to be the plus 11/6. Okay, now once you know that, then you've got the x and the y value, and now you just use your formulas for unit circle trig. So all we've got going on here is that the secant of theta should be 1 over the x value, which is 1 over root 11/6, which is 6 over root 11, which is 6 root 11/11 if you simplify. The answer above that is fine as well. The other one, cotangent theta, is x over y. So the x value is root 11/6, and the y value is -5/6. 6's cancel, so we get negative root 11/5. And there's your other answer. Okay, so pretty straightforward. The thing that was different compared to previous unit circle trig problems was they gave me the y value but not the x value, and I had to calculate it. So that wasn't that bad. Draw a little picture, and then you can figure out the x. Okay, so that's it for now. I'm going to have to leave and start my Zoom hour. Hope to see you there. Although you've already missed it by the time you're watching this.